Hello and welcome to another section in further maths. In this section, we'll be talking about ratio of general angles. You know, I could still remember in the last section we talked about the first and the second quadrant. Now, before we move into what we have for today, I would like us to take a good look at our previous lesson. Okay, welcome back. You know, in our previous lesson, we said something about sine theta. Let me just keep it as a point of reference so that we make use of them. Cos theta and tan theta. We stated clearly that these are the major trigonometric functions that we use in analyzing ratios and angles. I'm trying to get relationship and the value in each of the quadrants. So we've done justice to the first quadrant. We did justice to the second quadrant. I think at this point I'd like us to consider the third quadrant. But remember, the first thing we are supposed to do is to produce a circle. Okay, yep. Then dividing it into the 4 cardinal points. Okay, stating the obvious. You know, I made use of the word obvious because we are used to the process of naming it the positive y-axis, the positive x-axis, the negative y-axis, and the negative x-axis. Now, I stated clearly in our previous lesson that this point is called the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And we have 360 divided by 4, which is 100. We have 90 degrees. So 90 degrees, that's to say everything that has to do with the first quadrant is 90, second 90, and third is this. Now I want us to design, let's produce an angle, project it this way. Okay, let's call here theta, because this is the third quadrant. And remember, in the third quadrant, y assumes a negative value, so this is minus y. The x here is also negative, which is minus x. P is always our resultant. If you want to make use of, if you want to resolve the vertical and the horizontal components using the Pythagoras theorem, so we place it at the neutral point. We don't use the word either positive or negative in classifying it. So with what we are seeing in front of us, I want us to apply sine, cosine, and tan. But remember, from this point to this point is 180 degrees. So from here to this point, where the arc is, where theta started, is 180 degrees plus theta. So with this, let's go into sine theta is equal to remember the rule, SOHCAHTOA. Let's also state it here. SOHCAHTOA. We stated clearly that S is for sine, C is for cos, and T is for tan. And I stated earlier that O means opposite, the side opposite the angle. H is the hypotenuse, the longest side. A is the adjacent, that is the third part of this right angle triangle. So now let's look for the value of sine theta. Sine, we have opposites. The opposite of theta here is minus y over the hypotenuse here is p. So you can see that sine in the third quadrant always have a negative value because you have minus y over p. Now we also deal with cos theta. Cosine states adjacent and hypotenuse. What's the adjacent? Minus x hypotenuse over p. So this is minus x over p. That is to say, cosine in the third quadrant is also negative. Now the last one we have to deal with here is called tan theta. And we're talking about tan theta. You have opposite of it is minus y over adjacent over minus x. So minus deals with minus, we now have y over x. So the only positive function we have in the third quadrant is tan. So this is trying to tell us that if we have values that ranges, initially I stated that in the first quadrant the value ranged from 0 to 90, second quadrant above 90 to 180. So in the third quadrant we have from 180 to 270. So if you have the value of x being greater or equals 180 and less than or equals 270 degrees, at this point sine is usually negative, cosine is negative, and the tangent of such angle is positive. When we did that of the second quadrant, we discovered that it was only sine that is positive. In the third quadrant, sine is now negative, cosine is negative. And when we want to talk about the angle of equivalence, just like what we did in the second quadrant, our angle of equivalence was 180 minus theta. At this point, it's 180 plus theta. So let's go into dealing with sine. Let's start with number 1. This serves like a proof to what we just discussed. If we have something like sine 210 degrees, 210 is greater than 180 but it's less than 270. So 210 now is the same thing as sine 180 plus 30. So which is the same thing as sine 30, because we are considering the angle. But remember, sine is negative in the third quadrant, so you add the negative sign. So, and you know that sine 30 in a normal trigonometry is 0.5. So sine 210 will be minus 0.5. I would like you to confirm this using whatever means you feel is suitable for you. Now in the second part, I want us to deal with cos 190. When you have cos 190 to deal with, so at this point it's same as cos 180 plus 10, which is the same thing as cos 10. But remember, cosine is cos in the third quadrant is negative, so a minus cos 10 will give us minus 0.9848. That's for cosine. Then we also have the last one. Let's do that of tan. Remember, tan is the only number that assume. Let's use tan 240 degrees. Tan 240 should be the same thing with tan 180 plus 60, which is the same thing as tan 60, and the value of tan 60 is 1.732 with a positive sign. Now you can see that at this point it's only tan in the third quadrant that has a positive value. Now in the second quadrant it was only sine. In the third quadrant it was tan. Now let's go to the last quadrant, which happens to be the fourth quadrant. The fourth quadrant. Remember, we have a circle being divided into 4 parts, and this is the fourth quadrant being projected, this angle. Now this is, remember, these are x, these are y, these are minus y, and these are minus x. So at this point is in the negative y axis, so this minus y, positive x, and these are p. So with this we have sine theta is equal to, remember SOHCAHTOA when you're dealing with this, SOHCAHTOA. So this for sine, cosine, and tan, just like what we've been doing. So for sine theta is opposite, which is minus y over hypotenuse p. So this is also a negative value. for cos theta is equals adjacent. The adjacent is x all over hypotenuse, which is p. So cosine in the fourth quadrant has a positive value, and we also have tan theta. Tan is opposite, which is minus y all over adjacent x. So tan in this quadrant also assumes a negative value. But with this, you know that this is the point. Okay, 360 minus theta should be what we'll be having in this quadrant, because the total circle forms a 360 degrees. So the angle of equivalence from this point, you know, here is from this point to here is 360 minus theta will be the angle of equivalence. So I would like us to test what we just did at this point with the following questions. What is the value of sine 300? Now the first you're supposed to ask yourself is, sine 300 falls in the fourth quadrant because it is above 270 but it's below 360. So any answer you're getting, just know that it should be a negative value. But we apply angle of equivalence that says 360 minus theta. So if you do 360 minus 300, we have 60 degrees. So it's the same thing. Sine 300 is equivalent to sine 60, and the value of sine 60 is 0.8660. But since it's a member of the third quadrant, you put the minus sign because you're talking about 300. So the value of sine 60 will be sine 300 will be minus 0.8660. So, and if you want to consider that of cosine, let's say cos 280, cos 280 will be the cosine of 360 minus 280. Cos 360 minus 280. So with this, 360 minus 280, we'll be having 360 minus 280. Let's just do a single, which is 0.80. Okay, that's 80. So we'll now have cos 80 degrees. So cos 280 is the same thing as cos 80 degrees, which is 0.173 Now at this point, there's no negative sign being attached to it because it is found in the fourth quadrant. And I just said, so we just proved now that in the fourth quadrant, cosine is always positive. So if you check, the value of cos 280 is the same thing as the value of cos 80. Now the last part of it is tan. Let's use tan. Okay, 330 is still a member of that range because it's greater than 270 and less than 360. So if we have something like this, remember the rule is the same thing as tan 360 minus 330, which is the same thing as tan 30 degrees. But it's in the fourth quadrant, we add the minus sign. So tan 30 degrees is equals 0.5774. But you add the negative sign to it, so tan 330 will now be equal to 0.5774. So in order for you to refresh your memory on what we've just discussed, take the test on the screen. Do well to use the lesson note on the platform for better information on the topic we've discussed. Thank you. See you in our next lesson.